The producer-consumer problem is almost a design pattern. It's a very classic synchronization and inter-process communication problem, which has many different applications. So what we are going to do is we're going to study a very simplified version of the producer-consumer, which involves two processes. One is a producer and one is the consumer. Those two processes share a mean of communication. In this instance, they share a segment of shared memory that is big enough to just contain an int. And they are going to communicate one int at a time, and progressively we are going to implement a solution where they don't only communicate but also synchronize to make sure that each int that is passed with integrity, which means all the bits are there before they are started to be read, and also we are going to make sure that no integer that is passed through this communication channel is ever lost. So what you have here to start off with is the solution that we are going to implement as a pseudocode. Okay, so we are going to skip over this real fast because we are going to come to this solution here, the complete solution, in 3 steps. The first step will not even use any semaphore at all. Okay, in this first step we are going to set up a shared memory to share a single int in the producer. So the producer will be our first program to write and the first process to execute. It will set up the shared memory and then it will iterate for 10 times, and every iteration it will write the number of the iteration to the shared memory, then sleep a random number of seconds between 1 to 5. So for 10 times we are going to write 1, then 2, then 3, then 4, then 5, etc. Sleep 1 to 5 seconds randomly in between, and write again another number in the shared memory. So when we test our program, we'll start the producer in a window, in a console, and then we will start the consumer in another. And this second process, the second program here, will pretty much set up in our first version only access to the shared memory segment. We won't use semaphores for version 1. And then for 10 times it will repeat, displaying whatever number is in the shared memory right now, and then sleeping for a random number of seconds. So that's going to be our first version, which is pretty much shared memory only. No semaphore, no synchronization, nothing. So this is the output we want to see. Each process will display on the screen producer or consumer, and it's going to display, for example, I'm writing and the number it's writing, I'm reading and the number it is reading. Okay, well, let's take a look at the code that is going to help us do that. So we have 2 separate files. All right, one file is the producer, which I called prod.v1.c. One file is the consumer, which we're going to come to that in 1 second. There's some boilerplate code here already that I got rid of. For example, all the includes that we are going to use are already there. So this is a good starting point. If you don't know where to start, I'm going to read you through this code that has like big milestones to follow, and then you can try to fill in the blank by yourself. What we do here, if you're not familiar with it, we initialize our pseudo-random number generator based on the current time. That allows us to run this program several times in a row and not have the same random sequences. The part that follows is just declaration, commented declaration, so it's pretty much self-explanatory, of all the variables that we are going to need to operate on our shared memory. So generally it's good usage to have somewhere the size of the shared memory segment you want. We are going to assign to this size the size of an int. Okay, because our shared memory segment needs just to be big enough to hold an int. We are going to need to store the ID of this shared memory segment. We are going to need to store the key of this shared memory segment. And once the shared memory segment is attached, we need a pointer. And we use here a char star to be able to access this shared memory. We could have used actually here int star. That would have been a little bit more clean. Printf, what shared memory key should I use? Read an integer from the user, store it in the variable shm key. Getchar, what do we use a getchar here? Well, the scanf, if you type my key is 1, 2, 3, 4, 5, 6, enter, the scanf is going to read 1, 2, 3, 4, 5, 6 from the input buffer, but it's going to leave the \n inside the input buffer. That means the enter key, pretty much, the enter key code. So by doing a getChar, we just consume the next character in the standard input, which is this return character. And this is going to allow us to pretty much clean up the standard input buffer. If we don't do that, later on when you ask here, press enter when ready to destroy the shared memory segment, and you do a getChar, well, if you do not have this getChar here at line 21, what happens is that the enter key that you pressed here to enter your number is still in the input buffer and will be consumed by this getChar. Therefore, I'm making you skip that step without really waiting. So this is why we have this extra getChar here. Then we have main milestones. Okay, create a brand new shared memory segment, attach this memory segment. This is a regular procedure to use a memory segment, a shared memory segment. Then we are going to produce some data since we are in the producer. So how do we do that? Simple loop. Okay, for I equals 0, I less strict than 9. So it should be less strict than 10 if we want to iterate 10 times here. I plus plus. And I'm going to do what? I'm going to generate a random number between 1 and 5. Okay, so this is the formula that you probably covered in COP 3515. If not, just use it as a recipe. Printf on the screen, producer, I just wrote the number I inside the shared memory segment, and I'm going to sleep for R&D seconds. Flush to make sure the display goes out before we sleep. Sleep for R&D second, and go and do that over and over and over. Once we're done, detach the shared memory segment, little typo here, and we'll then ask the user to press enter. That will allow us to let the consumer finish its job before we actually hit enter here and destroy the shared memory before to exit from this program. The consumer, let's take a look before we start coding. It's going to have a lot of code that is common. Okay, initialization, the include first, I should start by that. The include statement are the same. Initialization of the pseudo random number generator, same thing. We need the same variable to get a handle on our shared memory segment. I'm starting by asking the key. I determine the size of the shared memory segment, and my steps then are as follows. Open an already existing shared memory segment, so that's going to be different than for the producer. Attach it, it's going to be the same thing. Then read data from the shared memory segment. Well, pretty much I have the same type of loop here. I need to read 10 times, I need to perform 10 times the following operation, which is going to be read, and I didn't put the code yet here, read a value from the shared memory segment and store it in my local variable int value. Then determine a random time to sleep. Display on the screen and flush, I read the value, whatever you read, and I'm going to sleep for R&D seconds, and then sleep for R&D second, and move back to our loop. Once we are done, we detach the memory, the shared memory segment. We don't destroy it because we follow the guideline that every process that creates an IPC mechanism is sole responsible for destroying it, which is really common when you think that, for example, there could be one producer but 50 or 70 or 300 readers. In that case, it's definitely logic that the producer is the one that sets up everything and destroys everything when we don't need those resources anymore. So that should get you a good overview of this assignment, and the next videos are going to implement version 1, then we're going to move to version 2, version 3, etc.